as we did some of the other ones in class. If we have time at the end of the video, we'll go back and do the first two. So it says describe the behavior of the graph at each of these zeros. Well, above the x we have a 1, because above the quantity x plus 4 we have a 1, and above the quantity x minus 1 we have a fourth power. So at x equals 0, we know we are going to cross the x-axis. We know at x equals -4, we're going to cross. And we know at x equals 1, we're going to be tangent. And we know that if we were to FOIL, this function is to the 6th power, right? So we know right in here, -4, 0, and 1. If the leading coefficient's positive and the power is even, at x, so at 1 we're tangent, which means if it's like that, it would have to be up. At 0 we cross, which would mean it would come down. At -4 we would cross. So the graph would look something like that. How I got -4 is I set x plus 4 equal to 0 and solved. How I got x equals 1, I set x minus 1 equal to 0 and solved. Let's continue down. So for this next one, we know that quantity x squared plus 9 is power 1, x minus 1 is power 5, x plus 2 is power 2. So let's set each parenthesis set equal to 0. So if we add 1, we get x is 1. Now at 1, right in here, since the power is odd, we're going to cross the x-axis at x is 1, right? If we solve x plus 2 equals 0, we get x equals -2. So we know because x plus 2 has an even power, we're going to be tangent at x equals -2, meaning we're bouncing, right? Tangent means if this is -2, you come down and bounce back the other side. Or it could look like that, depending on the graph. So we know that because x squared plus 9 is to the 1st power, we know that this happens an odd amount of times, so it would cross. However, when we solve this, we see that we're going to have imaginary values. So your graph is really only going to cross the x-axis at 1 and tangent at -2. Let's look at the next one. What are the real and complex zeros of the polynomial function? So we see right in here that we cross the x-axis at x equals 3. We're going to use that information to factor to keep solving to find the other values, because we know if it's power 3, we know we should have 1 x equals, 2 x equals, 3 x equals. Now we already have 1. We know x equals 3. It touches the x-axis there. I don't see it touch anywhere else, but I know I'm going to have imaginary or complex, right? So we put the 3 on the outside in front of degree 3. It's a 2, -8, 9, -9. We have a 2. 2 times 3 is 6. -2, -6. 3, +9, 0. Okay, if it started cube, we drop a degree, so we have 2x squared minus 2x plus 3. We can see if there's a combo that multiplies to 6. A times c, that adds to b. 1 and 6, 2 and 3. No, there isn't, so you have to use quadratic formula. So negative b plus or minus square root of b squared minus 4ac all over 2a. So we have x is 2 plus or minus, under there we have a 4. -4 times 2 is -8. -8 times 3 is -24. over 4. So we have 2 plus or minus square root of negative 20 over 4. Square root of negative 20 we can break down, and 20 is 5 and 4, which is 2 and 2, so it's 2 plus or minus 2I root 5 over 4. So we have those two imaginary values. So we have 2 fourths plus 2I root 5 over 4. We have 2 fourths minus 2I root 5 over 4. So I'm going to write those up here on the left, and I'm going to simplify. So 2 fourths is 1/2. The 2 and the 4 can simplify, so we have plus I root 5 over 2. And the other one we also have 1/2 minus I root 5 over 2. So we have those three values. We cross at x is 3, and we have two complex values. Now on the next page. So for this page, it says, what are all of the real and complex zeros of the polynomial function? So we first want to look at the picture and see if we notice any. So right here, we see at -2 and at 2, we cross, right? So we know, because it's power 4, I'm going to write x equals 4 times. I already know that I have x is -2 and x is 2. Now we need to find the other ones. So I'm going to do synthetic division. Use one of the zeros. I have in front of degree 4 a 1. Degree 3 is missing, so we'll do a 0. Degree 2 is a -3, constant. So in front of degree 4, in front of degree 3, degree 2. Oh, we need a 0 for x. So it's kind of messy. Like that. Okay, so we have a 1, a 2, a 2, a 4, a 1, a 2, a 2, a 4, a 0. I know there should be no remainder because why should there be no remainder? Because I know that x is 2 is a 0 x-intercept. So now I drop a degree. Watch, it was degree 4, so we have 1x cubed, 2x squared, 1x, and 2. So now this is what we're working with. X cubed plus 2x squared plus 1x plus 2. But now we can drop a degree by putting the -2 on the outside. We can do it two ways. So we can do -2 on the outside, and I'll do that in a sec. Or you can factor from here. So we have x cubed plus 2x squared plus x plus 2. Is there GCF? No. Left pair, x, take out, you have an x, take out an x squared. So we have x plus 2. Over here we have x plus 2. We put a 1 in front. So we have x squared plus 1 times quantity x plus 2. And then you can set both of these factors equal to 0 and solve. So you'd have plus or minus square root of -1. Over here you'd have -2. So you have another -2. And then you have plus or minus square root of -1, which is plus or minus I. We already wrote the -2. So we have plus I and minus I. So you can either factor or you can use synthetic division. So we have a 1, a 2, a 1, 2. You always work with the smaller polynomial expression. So we have a 1, a -2, a 0, a 0, a 1, a -2, a 0. So then what's left here dropped a degree from this line, which was cubed. So then this is x squared, 0x, and a 1. So you can set x squared plus 1 equal to 0, which was plus or minus square root of negative 1, which was plus or minus I. Let's go back to the top for a second in case you missed some of it in class. Remember, you can copy your whiteboard work up here if you'd like. So it says factor the function, use zeros to sketch. So we can look for a GCF if it says factor. So is there a GCF? Yes, it looks like there's a 4 and an x. So we'll have x squared plus x minus 6. Now let's see if we can break this down. Is there a combo that multiplies to negative 6 AC that adds to b to 1? 3 and 2. The 2 is negative, so we would have x plus 3, x minus 2. So GCF's in front, x plus 3, x minus 2. And if we set each of these equal to 0 and solve, x minus 2 equals 0. So we have x is 2. We have x is negative 3. We have x is 0. So we're going to do a dot on x0, x negative 3, and x2. Negative 3, we'll sit right there. Okay, leading coefficient is positive, so we know we're up over here. Degree is odd, so we're going to be down there. And we know we're going to cross at each of these because each of them had power 1. So we're going to go like this. Bam. We know we're crossing there. We know we're crossing there. And we could plug in some values to see what's happening. So we could plug in negative 1 if we wanted. So 4 times negative 1. 1, negative 1 plus 3, negative 1 minus 2. So we have negative 4 times 2 times negative 3. So 8, 6, 24. So we would have negative 1 comma 24. So that would be way up here, right? And then we could plug in something in here. So we could plug in 1. So if we plug in 1, we'd have 4 times 1 times 1 plus 3 times 1 minus 2. So we have 4 times 4 times negative 1, which is negative 16. So we would have 1 comma negative 16. So something like that. There's a rough sketch. Okay, let's do this last one. So for this next one, it says factor. We're going to either try to fit to difference of squares or cubes. Now, I can't fit to cubes, so I'm going to try to fit squares. So square root of 81 is 9. This has to be x squared. Shh. Boomer, stop. Shh. So this is a, this is b. So we have a squared, sorry, x squared minus 9 times a, b. Okay, so we can set each factor equal to 0 and solve. So we'd have x squared equals 9, x equals plus or minus 3. So we would have, if this is 2, we have a 3, and we have a negative 3. And over here, if we set x squared plus 9 equal to 0, we would get plus or minus 3i. So we're not going to see anything touch the x-axis there. Leading coefficient is 1, so we're positive. Degree is even, so we're going to be balanced. And we know if we're crossing here, we're going to come down. Assume we're going to come back up.